Hello and welcome to a short video by the Hoylake Computer Club. In this video, we're going to do a solution to a problem, and the problem is the generate an identity matrix of size n, or size by size. Now, this is a common sort of interview question. I'm just arbitrarily choosing Python, but you can do this in JavaScript, you can do it in whatever language. We're going to do the plan first, and then we're going to kind of move forward with actually coding it up. I don't want this to be super, super long, so let's jump on it. Right, so I've got the problem here in a REPL. So here's the problem. Generate an identity matrix of size by size. Let's have a look at the description. An identity matrix is a 2D array holding all zeros except a diagonal line from the 0th element to the size -1 to size -1 or -1. That consists of ones. So that means, here's an example, that means that, see these ones here? So everything's a 0 to start with, but all of the ones are a diagonal down from the beginning, 0, 0, all the way to size -1, size -1. So it just draws a diagonal line of ones down there. So we need to generate this. That's the problem we got. Here's an example of an 8 by 8. Notice how we've still got these 1, 1, 1, 1, 1 in a diagonal all the way from first area all the way to the end there. To do this, personally, I'm going to say let's do it in sort of a two-step process. There's a few steps here that you could take. You could do some nested looping and make it a bit complex, but I'm going to try and go with a simplistic approach. So let's start with the thought of, well, what do we want to do? We want to create some sort of a matrix, say an empty matrix. That's my first thing I want to do. Just create this empty matrix. Now, then I want to start append a list of size. I'm going to say n. I'm going to change the word size there to n so that I don't have to say of size because it makes no sense. So append a list of size n filled with zeros to the matrix. So that's part of what I want to do. But I'm going to say iterate over a range of, we'll say, n. And then within there, for each iteration, I want to then append a list of size n filled with zeros to the matrix. Yeah. So we've now got kind of the idea of a loop here. So for every single iteration of n, we are going to append a list of size n filled with zeros to that matrix. So that will kind of be our first step. Get this to be a bunch of zeros. Yeah. Then after I've done that, I can then just iterate over it again. So make it kind of an O of n time complexity. So let's say we then iterate over a range of n. In doing this now, let's say extracting the index I will say. So now I can refer to each of the indices as I. So the first iteration of it will be 0. Now remember, we want to put 0, 0. We want a 1 there. So if I say now, set the content of matrix at the address of, at the index of I to 1. So that in essence will, when I is equal to 0, it'll be pointing here. When I is equal to 1, it'll be pointing here. When I is equal to 2, it'll be pointing here. When I is equal to 3, and so on and so forth, until it reaches n minus 1. So that would be the algorithmic equivalent of what we want. Once we've done all that, we can then just return matrix to the caller. And you're done. Literally. I'll call this, I'll say matrix list here, because it's just going to be an empty list. How cool is that? I think that's all we need in my way of thinking. What we're going to do is we're going to do the first step and see that it's doing what we expect it to do. Then we'll jump in and do the second step. So let's jump in and start coding this up. I'm literally going to do that. There's my plan. So first I'm going to make matrix, which is going to be an empty list. Then I'm going to iterate over a range of n. So for, I don't particularly need to use I or anything there. So for blah, blah in range of n, let's say append to the list. So we want to append to this matrix. And what we want a bunch of zeros. We want that bunch of zeros to be the size of n. Yeah. So we're just going to append like n zeros in a list to it for each iteration. Let's see if let's jump down to return matrix and see whether it does what we expect for the first part. This is just that first little bit that we're doing. We're doing this bit and this bit. We're missing out this bit just now. So let's see what it does for us. Wow, we've got a lot of things. Let's comment out some of these things and just do the 4x4 matrix. So let's run that again. Let's line this up so it kind of looks normal on a 4x4. Almost a little bit more. There we go. So now it's a bunch of zeros, which is great. It's not exactly what we want yet, but it's getting there. It's got a bunch of zeros, what we wanted. Now let's iterate over the range again, but this time we want an index of I. So for I in range of n. Now what I want to do is go and take that index it at, oops, not that index. Take that matrix and index it at I of I and I. And then just set that to 1. Let's see. Okay, now we've got an identity matrix of 4x4 because we gave it a 4. Let's try it with an 8. So I'm going to comment that one out. Let's bring that 8 back. Oops, bring that one out. Come down here and bring that 8 back. I'm going to run that. I'm probably going to have to resize so it kind of looks normal. Let's bring this back over about there, maybe a little bit more. Almost. There we go. So now we can see that the 8x8 is literally doing what we wanted it to. So it's passing that one fine as well. Let's try for a 16. This one's going to be somewhat bigger. Run that one. I need to kind of widen this out a bit then. Let's bring this one out somewhere here. No, a bit too far. Bring it over here a bit. Keep going until we kind of get a nicely lined up matrix. A little too far. There we go. So now if we look at this, we've got a 16 by 16 matrix where it is an actual ID matrix because it goes all the way down in the line. So there we have it. We have a simple sort of O of n operation, I'm going to call it. This is slightly arguably not, but for our purposes, we'll call it an O of n solution. It's using 2 loops. It's just doing some appends and jobs are good. So let's have a look that all of them are working. I mean, we've just tested them in isolation anyway. Let's just bang. That's got first, next one, next one, next one, that's fine. First, next one, and so on all the way through. Same again at the end, and we're good. This should work up to like however size you want, basically. It's there's your generator, done. So first thing, we planned it after understanding what it's expecting of us, and then we went off and wrote the solution. Thanks for watching. It's been awesome. Remember to like and subscribe. If you want to join the club, feel free to drop a comment on this video if you like, and we'll get in touch and we'll kind of see about you actually coming in person to the club and getting some stuff done. Have a good one.